This is a derivation of cosine law. To begin, we have a triangle ABC where A is at the origin 0, 0, B is at some point X, Y in quadrant 1, and C has coordinates B for the length of the base, and the Y value is 0 because it's running along the X axis. Of course, opposite angle C is side C, opposite angle A is side A, and opposite angle B is side B, or the base. Now, to derive cosine law, which will allow us to solve any triangle, sides and angles, not just right angle triangles, we are yet going to begin with a right angle triangle. Consider within a triangle ABC, if we drop an altitude down from point B, we have a right angle triangle here with a hypotenuse of side A, and one of the legs height. And then the other shorter leg over here is if you have the base going to point C, if you subtract out the length X, you have B minus X. Therefore, we can create a Pythagorean relationship here such that A squared is going to be equal to H squared, the height, plus B minus X, all squared. Now, we want to write cosine law in terms of the sides on the triangle A, B, and C. So we need to do something with the H and the X, but we need to turn to our primary trigonometric ratios in order to rewrite them in terms of the sides. For example, the height over side C is equal to the sine of angle A. If we're looking at the triangle from angle A's perspective, the height over C is equal to the sine of A. So sine A is equal to H over C. And if we rewrite that for H, we would say that C sine A is equal to H. We also need to substitute in for X here. So H is going to go in here, and we need to find an equation that will include X. Well, if we consider cosine of angle A, X would be the adjacent side. So the cosine of A is going to be equal to X over C. And if we rewrote this for X, we would say that C cos A is equal to X. And we will use that to substitute in for X. So let's write this out. We have A squared equal to H squared, which is C sine A all squared. And we also have this square of a binomial, of course, B minus X. If we multiplied out B minus X, we would get B squared minus 2bx plus X squared. Now we can do the substitution for C cos A in for X in the next line. So A squared, when we square C sine A, that gives us C squared sine squared A. We still have our B squared, but we're going to substitute C cos A in for this X, so minus 2bc cos A. And then we're going to square C cos A over here, plus C cos A all squared. Now I'm gonna write the square of C cos A up with C squared sine squared A, because we're going to be able to reduce this long equation. So a squared is equal to c squared sine squared a. And then squaring out c cos a, here we have plus c squared cos squared a. We still have our b squared, and we still have our minus 2bc cos a. If we factor out the c squareds from these first two terms, we're going to end up with the Pythagorean identity sine squared a plus cos squared a. We still have our b squared. We still have our minus 2bc cos a. But sine squared of angle A plus cos squared of angle A is simply equal to 1. So that whole term will simply reduce to c squared, giving us a squared is equal to c squared plus b squared minus 2bc cosine a. That is cosine law. Notice how cosine law begins with Pythagoras, and what comes after the minus 2bc cosine of a is like an adjustment factor for a triangle that is not a right-angled triangle for any scalene triangle. Also notice that the equation is bookended by side A and angle A. This is very important if you're going to use cosine law, that whatever angle you are using, the opposite side to it is on the other side of the equal sign. The side and its opposite angle have to be on either end of the equation. And here we have cosine law.